All right. Okay, year seven. So what we're doing today is we're going to look at the Cartesian plane, and we're going to look at some coordinates and how we actually read coordinates and place coordinates on a Cartesian plane. So first of all, I have to explain you what a Cartesian plane is. Okay, so Cartesian plane, we call it. So we'll have pretty much when we have a grid like this, okay, we have the y value, which is that, what do we call that, vertical line, and then we got the x values that go there. We call this the first quadrant. It's important that you know these. All right. We got the second quadrant. And then we got the third quadrant on this side. And then we got the fourth. And then we got the fourth quadrant. All right. So in a graph, normally we have values. So if you look at the right side of the x values or the horizontal line here, so you got, if I'm just going to write this in scale, so that's going to be 1, 2, 3, 4, and then we'll have on the other side -1, -2, and -3, and so on. Obviously, the middle is going to be 0, okay? And if I go up the y value of the vertical line, that's going to be 1, 2, 3, 4, and so on. And obviously, same thing with the bottom, -2, -3, and so on. So when we place in, I guess, coordinates in a graph in a Cartesian plane, we actually use the x value first, and then we put the y value. So for example, if I'm going to put a dot just right here, and if I'm just going to line it up with dotted line, okay, and that's where my position is. So that dot has a coordinate of 3, 3 and 1. Okay, we use the x value first, so that's x and that's y. As you can see, the 3 is on the x axis, we call it. I should write that as well. And we've got y axis. And 1 is on the y axis. Okay, that's how we read coordinates on a Cartesian plane. And if you had one, let's say on the third quadrant, let's put one run just here, okay, approximately. Okay, so that coordinate is going to be, first we look at the value on the x-axis, which is -1 to -2. So that's how you read that coordinate. And the middle bit is we call that the origin. That usually has a 0, 0, or just a 0 coordinate. Okay. So the reason why I showed you what that looks like, guys, is because we're going to use this information that we have here, and we're going to draw a linear line. A linear line is a straight line. Okay, we're going to have a look at how that is going to look on the graph when we are given an equation. Okay, so let's say if you have y is equal to, I'm going to give you an equation now. Y is equal to, let's go, x plus 3. Okay, we know this is a linear equation because the x doesn't have a power. When x doesn't have a power, it's a linear equation. Okay. So it means a straight line. Okay. And because x okay, has no power. So therefore, it is a linear. Okay. So if I'm gonna, first of all, I can't draw this. If I put a graph, Cartesian graph here, okay, with x and y axis, I can't draw this graph until I get coordinates, until I have value of tables, it's called, okay? So I need to first of all write down table of values, which means coordinates. Now, the way I do that is I need to substitute in some x values into this equation to get y value, and that x and y values that I'm going to have is going to be my coordinates that I'm going to use. So for example, all right, I like to start with x equals to 0. Okay, I want to see where y is when x equals to 0. So I'm going to put 0 in the middle. Okay, so if I write down the equation, and if I say sub, which means substitute, sub x equals to 0, then y is going to be 0 plus 3, and that's going to be 3. So when x equals to 0, which is that point, y is equal to 3. 1, 2, 3. Okay, so my line is going to go through that coordinate. So let me actually put 0, 3 coordinate there. Okay, so my line is going to go through that position. Let's do another one. Let's actually use now x is equal to 1. Okay, let's see what y is going to equal to. So again, I'll put the same equation, and this is the way I want you to do it when you're doing your workings out. So you go sub x is equal to 1, and let's find out what y is. So x is now 1, so 1 plus 3 is equal to 4. So let's find where x is, that's 1, and x is, so if I actually draw this line a bit up, because it was a bit short here, so my coordinate is going to be somewhere right here, approximately. Okay, so that coordinate is going to be 1 and 4. That's 4 there, and that's 1 there. All right, let me put that in the table as well. And now let's actually go to -1. Okay, and let's see what our y value is going to be. So we sub in, which means substitute, -1 for x, y is equal to -1 plus 3, and y is equal to 2. So my x value is -1, and I'm going to have to go find where 2 is, which is around here. So approximately that's where my coordinate is going to be. And I can actually write my coordinates position there. It's going to be -1 and 2. Okay, so you can actually see when I have, let me put that there. When I have 3 dots there, you can see the line merging. Can you see the line merging on the graph? So if I actually draw a line, it's going to come something like this approximately. Okay, and obviously it goes infinity, it doesn't stop. All right, and I just need pretty much 3 coordinates to roughly draw my graph. You can have more coordinates, but I recommend you to have at least 3. Okay, to see how your graph is going to look like. And if you look at your table of values, which is the table that I have here, if I actually put -2 and 2, we could actually find out what y is without doing a calculation, because there is a pattern that's emerged on the table. Can you see the pattern that's emerged on the y values? Yeah. So if x is -2, what do you think y is going to be? Yeah, it's going to be 1. And if x is 2, yeah. So you can see there's a pattern emerge. as well. If you don't get a pattern, that means you've done something wrong as well. So you can check your answers a lot of different ways. The linear has to be a straight line. If you're not getting a straight line, if you're not getting a pattern, so if you extend this table even further, all right, and you put down, 3, 4, 5, all right, we know that our y value is going to be 6, 7, 8. I don't have to do the calculation to find it. You can if you want to, but once you see a pattern, it's just going to be continuation of the same pattern. All right, so that's how we actually draw the line, and it's important that we have a table of values. And in our table of values, each x, y value that we have represents a coordinate. So I'm circling the coordinates now. So we can actually have a look at it. So let's have a look at negative number. So let's have a look at when x is actually equal to -2, what's y going to equal to? 1. Let's see if that's the case. Let's go up that and hit the curve. Once we hit the curve, we have to go towards the y value, and that is going to be 1. And we can see that on the graph. That is the case, approximately. Can you see how I got that coordinate? Okay, so that table of values should represent a coordinate or on the line. So it has to go through that point. The line is going through the coordinates that we have, or the points that we have on the graph. Okay, so you need to link that up. You need to make sure you understand that your coordinate has to go through the line has to cut through it, okay, and their position on the graph for you. So make sure you can link that up and understand that. And we use substitution method to find out our y value when x is equal to a certain number. But that's important as well. All right.